Today we're talking about operations with complex numbers. Just a quick review that a complex number or complex number, however you want to say it, has a real portion to it and an imaginary part. Like the number 3 plus 7i. 3 is a real number, positive 7i is an imaginary number, and when I add them together, it's called a complex number or a complex number. Again, however you want to say it. If you only had the real portion, so if only the 3 existed and the 7i did not, I would call that number wholly real because the whole number is made up of real numbers. If only the 7i existed and the 3 did not, I would call that number wholly imaginary because the whole thing is made up of an imaginary number. So now it's time to start adding and subtracting complex numbers. And in that case, we're just combining like terms. So real numbers can get added to other real numbers. Imaginary can get added to other imaginary numbers. So let's take a look. Here I have two complex numbers, 4 plus 2i plus 12 plus 5i. Portions, 4 and 12, I can add those together and I get a sum of 16. I can add the two imaginary numbers together. 2i plus 5i is going to give me 7. I end up with 16 plus 7i. Adding 8 minus 3i to 7 plus 4.8i, again we can add the two real numbers and the 2. 8 plus 7 gives us 15, and 4.8i minus 3i leaves us with 1.8i's. When I add 6 plus 5i to 8 minus 3i, I get 14 from adding the 6 plus 8, and 2 plus 3i, or I could say 5i adding a negative 3i. When we subtract, this is just like subtracting with polynomials. We still need to distribute the negative or subtraction sign through the second set of parentheses. The sign in front of the 3 and the sign in front of the 8i will absolutely change. Now I can combine like terms, 4 minus I, and I end up with 1 plus 14i. Or this one has a little additional piece to it where one of the i's is negative. You won't see this often, but it can happen. So remember, order of operations says I have to do what's in the parentheses first. Since I have parentheses within a parenthesis, I need to multiply that 3 and the negative I. And I'm going to end up with a negative 3i, of course. So I get a negative 5 and a positive 3i. Now I combine like terms. 5 minus 5 is going to cancel or add to 0, so I have no real numbers left. And 6i plus 3i add to 9i. That makes this number wholly imaginary since only the imaginary portion remains. Let's take a quick look at multiplication. Multiplying complex numbers is we're going to have to do some distribution. So let's multiply 10 plus 3i to 15 plus 2i. We distribute the 10 plus 20i, distributing the 3i and 15, and 6i squared when I multiply 3i times 2i. What we can do here is combine like terms. The 20i and the 45i combine to give me 65i's total. But we're not done yet. There's one more piece of simplifying numbers together. And that stems from it's another value. Remember how an I squared then equaled negative 1? We're going to change this I squared to a negative 1. Then when I multiply 6 times negative 1, that number just becomes negative 6. Now I have 150 minus 6 gives me 144 and of course the 65i, since it doesn't have anything else to combine with. Let's look at one more. 7 plus 2i times 4 plus 3i. I have 4 separate terms, right? 2 terms times 2 terms. I should have 4 terms in the end. I can combine like terms, of course. 21i plus 8i in the middle gives me 29i. And the I squared becomes a -1. I didn't go through all of the distribution pieces because you already know how to do that. If you need extra practice, and then multiplying the 6 times the -1 gives me -6. And now I have 2 more like terms I could combine. 28 minus 6 adds to 22. And of course I need to remember to add my 29i. That about wraps it up for today. Make sure you've written down the examples. Write down any questions you have so you don't forget to. Great day, and I'll see you later.